An angle is formed by two rays with a common endpoint. That common endpoint has a special name. It is called the vertex. An angle is formed by two rays with a common endpoint, and that common endpoint is called the vertex. If you look at our picture, this is one of the rays, SR. This is the other ray, ST, and they shared that endpoint. So S is the vertex of this angle. Now, just like with a segment, we have to learn how to write about angles in terms of geometry. And there's three different ways, depending on what they've given you, on possibilities to write it. You can name it by its vertex if there's only one angle at that vertex. So you could say, you put a little angle symbol here, you could call this angle S, because there is only one angle listed here at that vertex. You can name an angle by 3 points so long as the vertex is the one that's in the middle. So I could say angle R, S, T, RST, or what could I say? T, S, R. But notice what's in the middle? S. The vertex of the angle is in the middle. You can also name an angle by a number if there's a number on the inside. You could also say that this is angle 2. Questions on how to name an angle? Can I go to the next slide? Has everybody got that part copied? Okay. On the next slide, you're going to notice that they've put a couple pictures here. Just real briefly, I want to remind everybody that an angle, just like a line, continues on and on forever. So the interior also continues on and on forever. There's really 3 parts. They didn't label the other part. There's an interior, there's an exterior. What's the other part? Does anybody know? The actual angle is another part. It can't be, if I said where is R? Where is R? Is it in the interior or the exterior? Neither. Where is it? On the angle. Okay? Where's point Q? Interior. And that's all they're asking here. It's in the interior of this angle. Example 2 and 3 come from the other picture that's down here. It says, what are 2 other names for angle 2? And here's where angle 2 is. And it's looking for 2 other names that I can call angle 2. I could say angle E, B, C. What's the other one? CBE. Could I call any of these angles angle B? No. In fact, be careful before you answer this question. How many angles are in the picture? You're right. 3. There's 1. There's 2. There's 3, the whole thing. Okay? There's 3 angles. So the reason I can't say that it's angle B is I wouldn't know which one of those 3 angles it was referencing. So if there's more than one angle that's there at a vertex, you cannot use that vertex to name that angle anymore. You have to name it with 3 points or a number. Everybody good with the first 3 examples? Now, this is probably the biggest reason I copied them today, is because I didn't think everybody would have a protractor. And the truth of it is using a protractor is good practice, but when you go to take the EOC, are you going to use a handheld protractor? Where's it going to be? It's going to be on the computer, and it's a little different manipulating one on a computer than it is working with a handheld one. And every handheld one, like calculators, they look a little different. It is important to know that when you're using a protractor, that one side of an angle should be lined up with a line that's on the bottom. The vertex should be at 0. Now, the first one that they talk about, and I should talk about, they told me to find the measure of it, but there is a way that they could write it without writing out that word. Just like when we did segments, if you don't put a line over the top of it, it's talking about the measurement of it. Here, if they put a little m in front of it, they're saying what is the measure of that angle. Okay? AOD is pretty simple, because if I look at where it is, both of the numbers are the same. How big is angle AOD? 90 degrees. That's pretty simple. Somehow or another, it seems to me that people make mistakes with example 6, where it says FOA. Because there's how many numbers here? 2, and people seem to get stuck about which one to use. I think it should be obvious, but yet people make lots of mistakes. How big is this angle? This is 140 degrees. Let me ask you a question. Is this angle acute or obtuse? Obtuse. It's obviously obtuse. There's no way it can be 40 then, is there? The other thing that you should notice is when I'm looking at this angle and I'm measuring it, I have to start where there was a line on the bottom. Do I want to start at 0 or should I start at 180? When I'm measuring, I always want to start where? 0. So obviously I'm using the inside track, which brings me over to the 140 on the inside. Now, when I go to find angle EOC, It didn't start where? It didn't start at 0 in any case. Pick 2 numbers, either from the inside or the outside. Does not matter which, going to come up the same. Take the largest number. Subtract the smallest number. How big is angle EOC? 70. It's 70 degrees. If they're nice even increments like these have been, you could also count it. 10, 20, 30, 40, 50, 60, 70 degrees. How big is angle BOC? It's 20. 50 minus 30, 20 degrees. Questions about our protractor? Can I go to the next slide? Okay. This really shouldn't require much explanation. You should know these. But I am going to put the little definition out on the side. And the one that people are going to make mistakes on, believe it or not, is obtuse. You're going to know part of it, but not all of it. To be acute, it's an angle that is less than 90 degrees. To be a right angle, it has to be equal to 90 degrees. It is important to know that you cannot assume that something's 90 degrees. They have to put that little notation in the corner. The only thing that we really can assume is the straightness of a line. Although a straight angle is equal to 180 degrees, we typically call a straight angle a line. This is where people make mistakes. What does it mean to be obtuse?
More than 90, but less than 180.
Very good. It's more than 90, but it's also less than 180. And a lot of people forget about this second part. Questions about how to classify an angle, whether it's acute, right, obtuse, or straight. When they're talking about congruent angles, just like they've put hash marks on line segments, they can put marks in pictures like this showing that these two angles are congruent. Depending on the book that you use, some books use a single line like this. Some use a line and put a little hash mark on it. If there's more than one angle then, or one angle pair that's congruent, it might have a line on it with two little hash marks on it. If they're not using the little hash marks, they might put two lines if there's another pair of them that are congruent. What is important to know is if they are congruent, what should I be able to say about their measurements? They are equal. In other words, if I told you that angle 1 was 45 degrees, and I told you angle 2, I wouldn't even have to tell you angle 2. You would know angle 2 is how big? 45 degrees. Could I find this one that's missing? How could I find it? I'd add these two together. 45 and 45 is 90. How would I find this piece that's missing? I'd subtract it from 180 because I can assume the straightness of a line, and I know that it had to add up to 180 degrees. This would be a 90-degree angle here in the center if these were both 45. Everybody good? You all right? Next then, I'm going to skip some of these. They're all the same. Example 8, it says name the sides of angle 1. Here's where angle 1 is. It says name the sides. The sides are rays that have a common endpoint. Ray BA is one side. What's the other side? Ray BC. Those are the sides of the angle. So I'm going to skip where they're asking me to name the sides of angle 2 because it's done the same way. Give another name for angle 1. Look, angle ABC. There is one more. What else could I call it?
CBA.
I could call it CBA. Why not angle B? Because there's 3 angles at that point. Okay? I'm going to skip 11. It's the same as what we just did. Example 12 is like working with the segments. When they give you information about a picture, you need to put that information into the picture so you can see what to do. They said angle 1 was 3x plus 4. Write it into your picture. They said angle 2 was 7x minus 2. Write that into your picture. They said angle A, B, E. In other words, the whole thing, they said, was 52. They asked me to find two things, the value of x and the measure of angle 1. This is just like the segment addition postulate. It's the angle addition postulate, but it's exactly the same. It says if I know part of an angle, I know another part of an angle, that I can add those two pieces together and it should be equal to the whole thing. 3x plus 4 plus 7x minus 2 should be equal to 52. Combine like terms, 3x and 7x, 10x, 4, negative 2, plus 2. Get rid of the 2. 10x is equal to 50. Divide by 10. X is going to be 5. What about the measure of angle 1? Well, what did they tell me about angle 1? It was 3x plus 4. What can I put back in this place? 5. 3 times 5 plus 4. 19 degrees. Yep. If I were going to write it out, I would write the measure of angle 1 equals 19 degrees.
Can you get points taken off and forget the degrees?
I probably would not. I don't think that they do that on the EOC. I don't think they grade it that way, so to speak. I don't think they leave 19 as one of the answers and 19 degrees as one of the answers. I just don't think they play that kind of game. We all know that they have some tricky questions, but I don't think that's one of them. Do I need to work out number 13, or is everybody good? We understand the concept. Then your assignment is from your workbook. And you're going to do the 1-4G. It should be 15 and 16 in your workbook. You're going to do 1 through 13 and 19 through 29.